All right, imagine this. You're building something, and you need a part, a metal part. And it can't just be sort of round. It has to be perfectly round, smooth, like almost frictionless.
Yeah,
Like something you'd find in a car engine or a jet or, well, anything where precision is really key.
yeah,
I mean, how do you even make something like this, especially if you're working with metals that are super hard?
right.
Like, forget about doing it by hand. I can't even imagine getting that kind of
I
consistency.
don't know.
And even with a lathe, you're probably not going to hit those super tight tolerances or get that, I don't know, that mirror finish. So how do they actually do it?
Well, that's where CNC external cylindrical grinding machines come in. And that's exactly what we're diving into today.
Okay, so CNC, so we're talking computer controlled.
Absolutely.
Well, what about the rest of that? Break it down for me.
So basically, it's a machine tool that uses a grinding wheel instead of, a traditional cutting tool.
Oh, okay.
And it's specifically designed to grind the outside diameter of cylindrical workpieces.
So we're talking about getting that perfect outer surface.
Exactly. And when we talk about precision, we're talking about achieving accuracy down to a few microns. To put that into perspective, that's thinner than a human hair or even a strand of spider silk.
Wow. Okay, so seriously precise.
Seriously precise. And the surface finish, it's incredibly smooth and fine.
Gotcha. So it's not just about making something round. It's about hitting tolerances that are, I mean, almost unimaginable, and a level of smoothness that's critical in, well, like you said, car engines, planes, anywhere where even the tiniest imperfection could cause a problem.
Right. It's about performance, safety, the whole deal. And what's really interesting is that these machines can handle a huge variety of sizes. You could be working on a tiny pin for a medical device or a massive shaft for a power plant turbine.
So small scale to industrial scale.
Exactly. So the principle, precise external grinding, applies across a whole spectrum.
All right, so we know what they are, but how do they actually work, these machines?
Well, it all starts with securely holding the workpiece, the part you're grinding. This is usually done in one of two ways. Between centers, where the workpiece is supported at each end, or in a chuck, which grips one end.
So like holding a pencil between your fingertips versus clamping it in a vise.
Exactly. Holding it between centers is good for long, slender parts because it helps ensure they stay round along their entire length. A chuck is more versatile. It can hold shorter or oddly shaped pieces.
Okay, that makes sense. So the workpiece is secure, then what?
Then comes the grinding wheel, which is kind of the heart of the operation. And these aren't your typical grinding wheels like what you'd use at home.
Right.
These are made from super hard materials like aluminum oxide or cubic boron nitride, often called CBN, and they spin incredibly fast.
Driven by the machine.
It has its own separate spindle, totally independent from the workpiece's rotation.
Interesting. So you have the workpiece spinning, the grinding wheel spinning, and then the CNC, the computer, comes into play.
Exactly. The CNC controls everything, the movement of the grinding wheel, how fast it feeds into the workpiece, everything.
Okay, so how does it actually, grind?
Well, it all comes down to controlled abrasion. The grinding wheel removes material from the workpiece, but it's done very precisely, in tiny layers, just microns at a time.
So it's not just grinding away, it's a very deliberate process.
Absolutely. And the CNC system manages this entire process, ensuring that the grinding wheel contacts the workpiece just right, removes the right amount of material, and creates the desired shape and surface finish.
Okay, that makes sense. So what types of movements does the CNC control? I mean, how does it actually manipulate the grinding wheel?
It controls a few key things. One is the infeed, which is basically how fast and how deep the grinding wheel moves into the workpiece.
So like how aggressive the grinding action is.
Yeah, you could think of it that way. Then there's traverse grinding. Imagine the grinding wheel moving back and forth along the rotating workpiece, like a paintbrush on a cylinder.
Right.
And the speed of that back and forth is the traverse speed. And then there's plunge grinding, where the wheel moves straight into the part, kind of like a cookie cutter.
Oh, okay, to create a specific shape.
Exactly. And on top of all that, the CNC also controls the workpiece's rotation speed and the final position of the grinding wheel to ensure that everything is absolutely precise.
So it's all about micron level adjustments and movements.
That's precisely. It's a highly coordinated dance, all controlled by the computer.
And this is how they can achieve such complex shapes and make sure every part is identical.
Exactly. And once you've programmed the process, the machine can run on its own, churning out perfectly consistent parts.
Pretty amazing. And what about coolant? You mentioned that before. What role does it play in the process?
Coolant is essential. It's continuously directed at the point where the grinding wheel meets the workpiece, and it does a few important things. First, it helps dissipate the heat generated by the friction.
Which I imagine is quite a bit.
Oh, absolutely. Second, it flushes away the tiny bits of material that are removed during grinding, the grinding swarf. And third, it helps to improve the surface finish of the part.
So it's kind of a multitasker.
Yeah, you could say that.
All right, so just to recap, we're talking about a process that's incredibly precise, computer-controlled, removing material in tiny increments through abrasion, way less room for human error than manual methods, and much more efficient for making these high-precision parts. But, earlier we were talking about lathes and how they can also make round parts.
Right.
So why would you go to all the trouble of using a dedicated grinding machine? What are the advantages that make it worth the extra effort?
That's the key question. Well, for starters, the level of precision you get with grinding is just unmatched. We're talking tolerances down to the micron level and geometric accuracy that's hard to beat with other methods.
So that's a big one, the precision.
Huge. And then there's the surface finish. We talked about how coolant helps with that, but the grinding process itself can produce surfaces that are incredibly smooth, which is essential for a lot of applications.
Right, like for seals or moving parts.
Exactly. And then there's the ability to machine hard materials. Things like hardened steels, which are super tough, are much easier to grind than to turn.
So grinding is really the way to go for those types of materials.
It often is. And then, of course, there's the consistency and repeatability that you get with CNC control. The automation means less chance for human error and the ability to produce parts that are virtually identical.
So it's about precision, surface finish, hard materials, and consistency. Sounds like a pretty compelling case for using these grinding machines.
It really is. And when you consider the applications, the kinds of parts that need this level of accuracy and finish, it makes sense why they're so important in industries like automotive, aerospace, medical devices, and more.
Absolutely. Okay, so the name of these machines is quite specific. External cylindrical grinding. This brings up a question. Can an external grinder also do internal cylindrical grinding?
That's a very good question, and the distinction is important. Most external grinders are really designed for just that grinding external surfaces. Their whole setup, the way they hold the workpiece, the grinding reels they use, everything is optimized for working on the outside diameter.
Okay, so not really meant for internal work.
Right. However, there are also universal cylindrical grinding machines.
Oh, okay. So that's where the internal grinding comes in.
Well, not always. Just because it's called universal doesn't automatically mean it can do internal grinding. It's important to check the specifics of the machine.
So how do you know if a universal grinder can actually handle internal work? What's the difference in design?
The key is often the wheel head. Universal grinders typically have a wheel head that can swivel, and this allows you to mount different types of grinding spindles. So for internal grinding, you'd use a separate, smaller spindle with a smaller grinding wheel. Ah, so you can swap out the tooling.
Exactly. But this does involve a more complicated setup, changing the wheel, adjusting the CNC program, and getting everything positioned correctly.
Gotcha. So it's a bit more involved, but it's possible.
Right. And some universal grinders are really impressive. They can grind internal diameters, faces, tapers, all sorts of things. And they can even do multiple operations in a single clamping, which is a huge time saver.
That makes sense. And you mentioned Studer as a manufacturer known for these versatile machines, right?
Yes. Studer and others, they really focus on this kind of multitasking capability in their universal grinders. They're designed for shops that need to work on a variety of parts with different features. But it's important to note that even with a universal grinder, internal grinding is often a bit more complex.
Why is that? Well, you're working inside a bore, so access is more limited. And you're often using smaller grinding wheels, which can be a bit less rigid.
Okay, so there are some challenges.
There are, but the flexibility is a huge advantage for a lot of manufacturers.
It sounds like it. So you've got these universal grinders that can do both internal and external work. It makes you wonder, why wouldn't every shop just get a universal grinder? It seems like the best of both worlds.
That's a fair point. I mean, having one machine that can do it all is tempting, but like with a lot of things in engineering, there can be trade-offs. Universal grinders are great for versatility, but they might not be the absolute best if you need the highest possible level of precision for a very specific type of grinding.
Ah, so it's a balancing act.
It is. If you're doing highly specialized work where you need to push the limits of accuracy, a dedicated machine, either for external or internal grinding, might be the better choice.
Makes sense. Can you give some examples of when a dedicated machine would be preferable?
Sure. Think about things like aerospace components, high-end optics, or really precise tooling. These applications demand the absolute best in terms of accuracy and surface finish. And a dedicated machine, which is specifically designed for that one task, might be able to achieve a slightly higher level of precision than a universal machine.
Okay, because it's not trying to do everything.
Right. And it's important to remember that even a universal cylindrical grinder is still designed for cylindrical workpieces. It's not going to be able to do things like surface grinding, where you're working on flat parts, or centerless grinding, which is a specialized process for high-volume production of cylindrical parts.
Right. Different machines for different jobs.
Exactly. So when you're deciding between a dedicated and a universal grinder, you have to weigh the need for versatility against the need for ultimate precision and the specific types of parts you'll be making.
So a lot to consider.
Absolutely. But understanding these factors can help you make the right choice for your specific needs.
Well, this has been a fascinating deep dive into the world of CNC external and universal cylindrical grinding. I feel like I've learned a lot about these amazing machines. Just to sum up for our listeners, we've talked about how CNC external cylindrical grinding is the go-to method for achieving super precise outer diameters and incredibly smooth surfaces. We've discussed how universal grinders can add flexibility by handling internal grinding as well, but they're not a perfect solution for every situation. And we've explored the reasons why dedicated machines might still be the best option for certain high-precision applications.
Right.
And I think the biggest takeaway is that choosing the right machine really depends on your specific needs, the kind of work you're doing, and the level of precision you require.
Couldn't agree more.
And it's amazing to think about how the technology is constantly evolving. With the increasing demand for precision in so many industries, who knows what kind of advancements we'll see in the future. Maybe we'll have machines that are even more versatile, combining the best of both worlds. The flexibility of universal grinders with the ultimate precision of dedicated machines.
That's an interesting thought. I mean, imagine a world where you could achieve micron-level accuracy on a wide range of features, internal, external, maybe even beyond cylindrical shapes. The possibilities are pretty exciting.
They are. It's definitely something to think about. All right, well, that wraps up our deep dive for today. Thanks for listening, everyone, and we'll see you next time.